What we find in trigonometry is that we end up relying very heavily on three particular angles: 30 degrees, 45 degrees and 60 degrees. And because we can rely on those angles and they come up so frequently in trigonometry, we end up wanting to have not decimal approximations for the angles, but we want to have exact ratios, which means if there's a square root sign within the ratio, then we keep that square root sign. So we'll start off looking at the exact ratios for the angles of 60 degrees and 30 degrees. What we do is we draw a triangle that's going to represent our 30-60 degree triangle. So we've got 60 up here in the biggest angle, and we've got 30 degrees down here for the smallest angle. Now what I always remember is this, that the sine of 30 degrees is equal to a half. And we already know that sine is going to be the opposite over the hypotenuse. So that means straight away that sine, the opposite, is going to be 1. Opposite the 30 degrees is 1, and the hypotenuse is 2. And you can quickly in your head do a little bit of Pythagoras' theorem to figure out that the third side in this triangle must be the square root of 3. Now if we work out the sine ratio for 30 degrees and the cosine ratio and the tangent ratio for 30 degrees, we find that cosine for 30 degrees is going to equal root 3 on 2, and also the tan of 30 degrees is going to equal 1 on root 3. So now we've got the exact ratios for sine, cosine, tan of 30 degrees. We're going to do the same thing for 60 degrees. If I have the sine of 60 degrees, then sine of 60 degrees will equal root 3 on 2, and the cosine of 60 degrees will equal a half, and the tan of 60 degrees is going to equal root 3 on 1, which is really just root 3. So we've got the exact ratios now for sine, cosine, tan of 30 degrees, sine, cosine, tan of 60 degrees. Let's have a look at the exact ratios for 45 degrees. It's the same principle. We're going to have a triangle, but this time the triangle is going to have angles of 45 degrees and 45 degrees. And now the simple thing is here, just in the same way that the two angles are 45 degrees, they're the same, we're going to make the two sides of the right angle the same length, so we make them 1 and 1, and then the hypotenuse of this right angle triangle is going to have a length of root 2. And now if I want to find the sine ratio of 45 degrees, what I get is sine 45 is equal to 1 on root 2, and that the cosine of 45 is also going to be equal to 1 on root 2, and that the tan of 45 is going to be equal to 1, because it's just 1 on 1. They're our exact ratios. They're going to be very important for later work.